Hi everyone. This is now the second part on solving the absolute value of a number. In the previous video, we were able to solve abstract forms of absolute value notations. And then we actually considered the operations that are found outside and the operations even found inside the absolute value notations before we simplify them. This video is the part two, wherein there are multiple absolute value notations that may be seen or multiple operations found outside and inside the absolute value notations. Well, you might ask, what is the purpose for these practice exercises? Do we actually use this in real life? The concern here is just to allow you to analyze further so that you can actually apply or improve your analysis when looking at the different operations and the different notations found inside and outside the absolute value notations. Let me show to you what I'm talking about. I'm sharing to you right now the practice exercise for part two, but still it's on the practice exercise C. Why practice exercise C? Because again, practice exercise A was made to or actually discussed the representation of absolute value in a real number line. And practice exercise B is the part one of the abstract form. We are now on the second abstract form. So we have here expressions that involve absolute value expressions or absolute absolute value notations, but they are still multiple operations that may be found inside or outside the absolute value notation. Let me look at number one. Okay, let's go to number one. Let us copy it here. So you have here the absolute value of negative 4 plus 4. The difference of this example from the previous example is that after you were going to simplify this absolute value notation, because the term is simplify, the task is simplify the expression, you still need to add it to a rational number outside. Okay, because if you say simplify, everything should be combined if things could be combined. So to do that, you isolate this first, not necessarily isolate. What I mean is you just simply copy the items without absolute value notations. So you have here plus 4 and simply get the absolute value, the result when the absolute value notation is simplified. So you have the absolute value of negative 4. Take note, again, we will say about absolute value um, notations, we take the positive value of the real number placed inside the notation. So the real number is negative 4. The positive for it is positive 4. And then again, we simply copied the items without absolute value notations. And then we add 4 plus 4 is equal to 8. As simple as that. Okay. So you just need to consider first simplifying the absolute value notation before adding the rest. But because you might actually say, I will add this first, sir, I will add that. So negative 4 plus 4 is 0 before I will take the absolute value notation. That's a no-no because again, this number here is just outside the absolute value notation. Let's look at number two. Number two, the negative of absolute value of 4 minus the absolute value of negative 4. So you have two different absolute value notations now. Okay. But again, the double negative property here will not be used or cannot be used because it's under the absolute value expression. And just to remind, I purposely placed number 2 here to remind us that again, not all answers of absolute value expressions are positive. Yes, when we simplify absolute value notation, we always take the positive value of what the real number is inside the notation, but we don't or we have no control with the operations outside it. So in this case, to answer that, simply copy this negative sign and here the minus operation. So the absolute value of 4 is positive 4 minus the absolute value of negative 4 is also 4. And then you have here negative 4 minus 4. This is not 0. I need to repeat. This is not 0. Again, I repeat, this is not 0. You go back to integers. You could actually use here the rule of successive alternate signs. Okay, because we know this is already plus, as it's actually the result of absolute value notation, and you can simply interchange the sign. So you have -4 plus -4, and then you're adding now two numbers with the same sign. The answer here is -8. So again, we always go back to the concept of integers. And then again, this is the indication that not all absolute value expressions will yield positive results. Only the real numbers or the simplified absolute value notations. Number three. Number three is or has -4, and then you have here -4 inside. If you see something like this actually means there's no operation here, clear operation. This means the product. This actually means the product of this number outside to the simplified form of the absolute value notation here. So this is still -4 times the absolute value of 4, -4, which is 4. And then you multiply. -4 times 4, you have -16. Right? Those are just, again, there are plenty of operations that may be found outside the expressions. So let's proceed to number 4. This is a longer one because you have multiple operations. You have 4 plus the absolute value of -4 minus 4 times -4. So we are treating them uh, into different operations. You could use GEMDAS, as I've mentioned last time. Gem. Yes. Let's start with the grouping symbol here. Okay. Or you could actually do also combine this, but let's just follow what we could actually express here in terms of GEMDAS. Uh, Pardon. So you have here, uh, yeah, 4. It's not working. 4 plus the absolute value of -4 is which is 4. Pardon, 4. And then minus the product of 4 and -4, which is -16. And then we apply here the double negative property. Or yeah, you follow GEMDAS if you want. So you have 4 times -4. Okay. And then you have 4 plus 4. Then your product of this is minus -16. And then you apply here the double negative property. So this becomes 4 plus 4. That's plus 16. See? It's now easy to look at this one if you will follow the step-by-step solution. Again, in mathematics, no need to rush. Do it step by step because what you need to develop is the skill, not the yes, speed will come in later on after you will develop the skill. But specifically, you start with the skill to with following the logical processes. That's actually 24. We still have two remaining items. So how different is number 5 to number 4? In number 4, you have a very long operations that will use the proper properties of MDAS. In number 5, still you still have that example, but basically you will have a division and multiplication of integers. So again, do not say I could cancel this, or I will use the cancellation law. Not yet. Yes, you may use cancellation law later as you will simplify the absolute value. Sorry. Uh-huh. As you simplify the absolute value notation. Okay. So you have here -4 still. The absolute value of 4 is +4 all over. The absolute value of -4 is +4. And then later on, you can use here the cancellation law and you will still have the answer of -4. Okay. So sir, is it It's okay for me to just cancel this out. I could just cancel this out and then I have negative 4 at the numerator. And I have negative 1 denominator. The absolute value of negative 1 is positive 1. So it's still negative 4. Well, magically, it would work on this number, but it's not a logical step because it will not work on the rest of the examples. Surprisingly, it works here, but it will not work all of the time. That is why my suggestion, do not use the cancellation law. Simplify first. As long as there are no more absolute value notations, you can now simplify. Okay, just like the stand for not applying the double negative property here, because we always simplify the absolute value notations first. Number six. Number six is a little bit tricky because actually you have an absolute value expression inside the absolute value expression. Okay. So this is the an absolute value expression inside the absolute value expression. So which absolute value expression needs to be simplified first? As what we have said, we always start with the centermost, or we always start with the items inside. So to simplify the items inside, we will not remove the outside absolute value notation. But we will remove the inside first. So you have negative 4 plus the absolute value of negative 4 is positive 4. And then do not remove first the absolute value notation outside because you still need to combine this. Negative 4 plus 4 is 0. So the absolute value of 0, or how far is 0 from 0? The answer is 0. Again, what happened to number 6 here is this. We did not remove the absolute value notation outside. We started first with whatever we can simplify inside. But to simplify the values inside the absolute value notation, we need to remove this first. So this becomes absolute value of 4 is positive 4. And we just simply copy this item here. And this goes back to the concept of addition of integers, which is actually resulting to 0. And that is where we will copy the last notation and of course simplify now. How far is 0 from 0? Is 0. Again, this is just a part to absolute value of a number to give you more analysis because in the previous item, we did not have plenty of operations or multiple operations outside. We may have one or two before, but we have now two or three operations, steps, processes. Do not be confused about the difficulty of the absolute value notations, okay? Um, Always go back to the idea of the absolute value notation, which takes the distance, the positive distance of the real number from 0. And then we just simply added the concepts of integers, operations of integers, so on and so forth. Because we need to uh, combine whatever information so that we could actually look at it into one. As you can see, just by doing the absolute value notations, you have been reviewing additions of integers, you have been reviewing subtraction of integers, the properties of integers, and how do we add integers using the MDAS sequence, or better yet, GEMDAS sequence. Use this video as your review for your assessment later on. Thank you very much. Hopefully you've learned. Goodbye.